clear this page. Now we've got a node and there are 5 elements connected to that node. We would like to write Kirchhoff current law equation, since there's a one node here. Kirchhoff current law equation for this node. How we are going to write this Kirchhoff current law equation? So Kirchhoff current law equation. In general, we know the Kirchhoff current law equation is summation of the elements current which are connected to a node is equal to 0. But this is algebraic summation, not simple summation, algebraic summation. So there is a node here, there are 5 elements connected to that node. These elements current, summation of these element currents is equal to 0, it says, and it says algebraic sum. When they say algebraic sum, what they mean is there is going to be a sign in front of it. So some of the currents are going to be minus sign and some of them plus sign. How we are going to do it? First of all, in order to say this, that means Kirchhoff current law equation, which is an axiom, we've got to do the same measurement. In order to do the same measurement means, in order to say the same measurement, we've got to choose a current reference. Otherwise, some of us say minus current, some of us plus current. So we've got to choose element currents in order to write an equation like that. So let's do it then. Here you are, the current reference for this B from left to right. So you can write the current reference outside the element, or you can draw it inside the element. And let's choose this one as this, and this one as towards the node, and this one out of the node. So summation of these element currents is equal to 0. But algebraic sum, how we are going to make the decision about the sign of these elements currents, there is a rule. I'll write a rule here down. It says if an element current reference is out of the node, then this element's current sign is plus. If it is towards the node, then sign is negative. So let's do it then. So this element A, the element current is towards the node, so it is minus IA. And B element current is towards the node, is minus IB. C element current reference is out of the node, coming out of the node, so it is plus IC. Towards the node, minus IE. And coming out of the node, plus ID is equal to 0, it says. If we choose the rule opposite rule, so that means when it is towards the node, it's going to be plus. When it is out of the node, it's going to be minus. So it's going to, in this case, our equation is going to be like that. B It's towards, so plus AB, C towards, out of this, so minus IC, and plus IE, and plus minus ID equal to 0. So the difference between these two equations is just the sign, isn't it? If you multiply this equation with minus 1, both sides, you get this equation. So mathematically those two equations, let's show it a bit that way. These two equations, this one and this one, mathematically they are the same equation. So why, since there are two rules that we can make, we are theoretical circuit people, they choose that rule. So this is the accepted rule. Let me put a different color here. So that is the rule accepted by the circuit theory people. So this is how we are writing it. So conclusion, in order to write Kirchhoff current law equation for a node, we have to choose the element current references randomly and then use the rule, write the equation. Pay attention that how you can check yourself whether that equation is written correctly or not. The number of elements you can check, one of the thing. The elements here there are 5 elements, so the number of terms in our equation is going to be 5 terms. If it is 6, if it is 4, that means there is something missing or some additional terms came in. So we've got to pay attention to that. That is how we are writing Kirchhoff current law equation, an explanation for you. So stop.